like August. So one project which has a manuscript currently under review in one academic journal, and with the title Machine Learning Models for Identification of Primary Water Concentrations in Mantle Pyroxene by Dr. Huan Chen. So please go ahead, Huan Chen. And the talk will last for approximately 12 minutes. So then we have a couple of minutes for interaction between the speaker and the audience. So please go ahead.
Okay, thanks. I'm Huan, a postdoctor from the Zhejiang University. And I'm very glad to give a presentation about our recent study on the machine learning to identify the primary water content in mantle pyroxene. Before this talk, I should thank to this student from the different university in China in helping us data collection, coding, and machine learning. First, I should introduce the background of this study. This is the Earth, and inside the Earth there are mantle, outer core, and inner core. And this rock is from the mantle. About 30 years ago, the geologists studied this kind of rock and find there are plenty of water in the deep Earth. And the water in the deep Earth is in form of the hydrogen defector in the minerals. And the presence of the water significantly affected the physical and chemical properties of the minerals and the rocks, and plays an important role in the evolution of the Earth and the deep water cycle. So the knowledge of the Earth's water content is therefore a wide-ranging significance. The first question is that how much water in the deep Earth? There are different opinions from some people propose that there are 4 Earth oceans in the mantle and 12 Earth oceans in the core. It's a lot of water. And some others propose that there are 7 Earth oceans in the mantle, and also some people suppose that maybe just 1 Earth ocean in the mantle. The reason for this is until now we don't have a good way to estimate the water content of the Earth. And in this study, I will introduce one of the most used way to estimate the water content in the deep Earth. There are mantle magmas because they are an important window into the water content of the Earth's interior. And there are different volcanoes on the Earth, and we can estimate the water content of different area. How to estimate the water content of the magma from the volcano? Here is a cartoon. We can find that during the eruption of the magma, the phenocrust will crystallize. The phenocrust is a kind of a mineral crystallized in the magma. And if we measure the water content of the phenocrust and using the hydrogen partition twin phase, we can calculate the water content of the magma. So this is a very simple way to estimate the water content of the magma. But there is a question about whether the CPX preserves the initial water content. And for the traditional geochemical methods, there are some traditional geochemical methods to evaluate this question, but all of these are not universally applied. The reason is that there are complicated substitution mechanisms for the hydrogen in CPX. For example, the hydrogen can incorporate in the T site, M1 site, M2 site. So it's so complicated, but what we know is that the chemical composition of the CPX records the information regarding the initial water content during crystallization. and the diffusion rate of other cations is many orders of magnitude slower than the hydrogen. So that means that the coupling between the water content and all the major element composition in the CPX can be used to identify the occurrence of hydrogen diffusion. But this relation is in a high dimensional space. So we can't use the traditional way to do these studies. So we suppose maybe we can use the machine learning. In this study, we use the spot vector machine, shortly called SVM. It is a widely used machine method for the purpose of binary classification. It is useful for our study because we just want to know whether the hydrogen diffusion occurred or not. The fundamental theory of the SVM is to find the maximum margin hyperplane between the two groups. And the most important thing is that the SVM can consider all the major elements composition and water content in the CPX simultaneously. So this is very important to us. And the scientific question of this work is whether we can use the approach of machine learning, for example, SVM, to identify the primary water content in the mantle pyroxene or not. So first step, this study, we should build a data set. In this study, we collected the major element composition and water content of the CPX phenocrysts in basaltic magma all around the world. A total of 2,249 data points on basalt host CPX phenocrysts were connected. Based on the results from previous studies, the CPX phenocryst data were divided into 3 groups. The positive examples that means that have not experienced hydrogen diffusion, and the negative examples mean that have experienced hydrogen diffusion. And the ongoing group is made by some samples, some well-studied samples, just for the variation of our trained model, and another samples we don't know whether hydrogen diffusion is occurred or not. So from the major element composition, we can find the negative samples, the green circle and the yellow circle unknown group are falling in the range of the positive examples. From this figure, it shows the similar things. That means that these 3 groups samples share the similar major element composition. For the hydrogen, we can recognize that there is poor correlation between specific major elements and water in CPX phenocryst. This is what I said, that we can't use 1 or 2 major elements to find the correlation between with the water. Here this picture shows the SVM modeling process. We have 2 datasets, training dataset and unknown dataset. For the training dataset, we divided into 5 groups randomly. And we conducted the SVM model with a 5-fold cross validation, and transfer the parameter to find the optimal model. And then use the train model to make predictions. Here, the black star represents the parameters of the optimal model. Here is the value of 2 parameters. And the evaluator results show that our trained model have got a high score, which means the good performance of our model. So for the unknown group, we first to conduct some model evaluation with representative cases. The first cases is that the Wade and his colleague studied a phenocrust from arc island basalt. They conducted profile analysis of hashing and find that the water content in the rim of CPX is lower than the core, means that the rim of the CPX underwent hashing diffusion. Here is the result of our practice. We can find the CPX at the rim part of the CPX are corrected as a negative samples, which is consistent with the previous study. And this sample at this point corrected as the next one may be the error of our model. Another case is the similar studies on the CPX phenocrust. They also conducted the profile study, and from core to the rim, the water content decreased, and they proposed that the rim of the CPX underwent the hydrogen diffusion. And here is our result. The green dots represent the negative samples, and this is consistent with the previous studies. And these two cases demonstrate that our model can effectively distinguish whether or not the CPX phenocrust in the basaltic melt preserve the initial water content during the crystallization. And then we made application. We applied to the CPX in basaltic magma. This study is from Huan and his colleagues. They studied. They tried to estimate the water content of the lithospheric mantle by the mantle derived the massive intrusions. The massive intrusions generally curly slowly, raising the possibility of hydrogen diffusion in the CPX, and they didn't give the strong evidence that the water measured in the CPX represented the initial. We can find this relationship is not so good, but our results provide show that most of the CPX grains are predicted to be the positive samples, and support their result means that this kind of basalt, those kind of magma have a high water content, and further support the hypothesis that the Pacific slab subduction provides the water flex to the North China crater and causing the destruction of the crater. So in summary, our work, in this work, the data on the water content of the basalt host CPX were connected around the globe. And we use the machine learning to model a binary classifier which can effectively distinguish whether hashing in CPX diffuse or not. And this model contributes to constrain the primary water content of the basaltic magma and the corresponding mantle source. So we go back to the first slide I showed you. Here in this study, we studied the CPX in the magma, the black part, and here this is the major composition of the mantle. And they call the peridot, they carried by the magma. And next step, we will study the water content in this kind of rock to constrain the water content in the lithospheric mantle. So thanks for your attention and welcome to join us. And if you want to know more detailed things, please send the email to us. Thanks.
Okay, thank you very much, Huan, for your presentation. So for the audience, if you have questions, feel free to ask questions or type your questions in the chatting please, and then I could read it for you. And if you don't speak English, it's fine. You speak Chinese, and I could do the translation. So go ahead.